You are an engineer and have been contracted to develop a model for an electromagnet to be used in a metal scrapyard. The electromagnet will be used to separate scrap metal from other non-metal garbage. Your client, the company that owns and runs the metal scrapyard, wants an electromagnet that can lift the most mass, but that is also the smallest size possible. Therefore, you are tasked with making a design for the electromagnet that minimizes the mass ratio of the electric magnet to the mass lifted by the electromagnet, its mass-strength ratio. Your task: develop an argument for the optimal design that is supported by data. To do this, you will first need to define the problem and identify your criteria and constraints. Then, you will brainstorm a solution, develop a design, and test your design against the criteria. After presenting to others and taking into account feedback from others and your own findings from the testing, you will make revisions to your design and then write a report to present your final argument. Your report must include background information, goals, your design with a description of how you tested it, your claim, your evidence, your reasoning. Be sure to include your writing, the decisions you made, and the rationale for your decisions that led you to arrive at your designed solution. Elaborations should include mathematical representations as well as narratives and label diagrams. Timeline for task. Day 1. Define the problem and identify criteria and constraints. Develop your design. Day 2. Finish your design. Test your design. Day 3. Analyze your data. Prepare your final argument. On the next page. Direction. Answer the question below in complete college sentences. How is this experiment different from the other one that you did last week? Performance task. Background information. How do we make electromagnets stronger? How should your design impact your magnetic field? What changes impact the electromagnet most? Why? Goals. What outcome are you expecting? Measurable. What are you changing to make sure the mass of the magnet is light? Rationale for design. Why did you design your magnet the way you did? Explain decisions made about components of the magnet. Did the results meet expectations? Procedures. Should include steps for final build. Should include steps for testing and recording data. Data collection. IV and DV in correct place. Average recorded. Graph. Checklist. Is there a title? Are your axes labeled? Is it evenly scaled? Is it graphed correctly? Final electromagnet proposal. What is the best design for the electromagnet considering the ratio of strength to mass? Claim. Describe your final design and the components that increased the strength of the magnet. Evidence. Should come from data of experiment and constructed graph. Reasoning. Defends the inclusion of evidence and why it is important or connects to the claim.